Okay, this is the key for Chapter 11 test. There are your answers to 1 through 7 with your formulas. Go ahead and pause it if you need to check those. I'm going to go straight into number 8. Number 8 says find the area of the figure. It's irregular, so what you need to do is break this thing up into some known rectangles. There are many different rectangles you could create. I'm going to draw that segment there and that segment there, and that creates 3 regions. This region up here, 4y times 2y, that's going to be 8y squared. Okay. Down here is 8 times 3, so that's 24, and then y times y is y squared. Okay. Um, Over here, it's y. Now, I have to choose between 3y or 2y. Which one's the actual length of this rectangle? It's 2y. 3y is all the way to there. Okay. So we'll go 2y times y is 2y squared. So 2y squared plus 8y squared plus 24y squared is 34y squared. So option C. Hopefully you understood the way I set these questions up. I tried to walk you through the entire process with 2 or 3 questions for each picture. The overall process is find the area of the heptagon. But, in the process of doing that, you need to know the apothem. It wouldn't hurt to know the radius. And then we can use that information to find out what the area is. So 9 and 12, or sorry, 9 and 10 will help you get to 11. Remember what we want to do is first create this triangle here. Okay. So when we create that triangle, we want to know what this angle with my cursor is. So we take, we can fit 7 of those triangles in that heptagon. So I take 360 divided by 7. So that central angle there is 51.42. I'll divide that by 2, and I get 25.7. So what I'm looking for right now, that 25.7 is basically that angle right there, 25.7. Okay. We know that this here is 5, and your apothem is going to be that length right there. Now, this is not a 30, 60, 90, so what you have to do is you have to use sine, cosine, and tangent. You know this angle, you know the opposite side, and the adjacent side is A, so you say a tangent of 25.7 is equal to 5 over A. Cross multiply, and that will eventually lead you to A equaling 5 divided by tangent of 25.7. So I will take 5 divided by tangent. Now, on my calculator, I could type in 25.7, but I want to be a little bit more accurate, so I'm just type in second answer. Now, my calculator is going to say, okay, we know that this A and S means to use the previous line as that value. So it's 5 tangent A and S. I want to make sure that my mode is in degrees. And now when I hit enter, I get 10.38. Okay? So A is 10.38, and looking here at our options here, the closest one would be B. Okay, so 10.39. So what's the length of the radius? Well, R. Okay, I could use R. I can use 5 is opposite. R is the hypotenuse. So I can say the sine of 25.7 is equal to opposite over hypotenuse. So now I'll multiply both sides, cross multiply, and I'll get R to be equal to 5 divided by sine of 25.7. So 5 divided by sine of 25.7. That's going to give me 11.52. And that's going to be for option A then. So 11.52 is option A. Okay. You could obviously, once you knew what this apothem was and you knew that this was 5, another way to find the answer number 10 would be the Pythagorean theorem. Okay, take 10.39 squared plus 5 squared, set that equal to R squared, and solve for R. Now it asks you to find the area of the heptagon with side length 10. That's a regular polygon, so the area is 1/2 the apothem times the perimeter. Well, that's 1/2. My apothem, we now know, is 10.39, and my perimeter is, each side length is 10. It's a 7-sided figure, so my perimeter is 70. And multiply all that out, you should get 363.65, which is option D. Okay. Um, Obviously, if you got the wrong apothem there, number 9, you're probably going to get number 11 wrong. Okay. So keep that in mind as you go through these things. Number 12. What is the area of the hexagon? Okay. Number 12 starts you off very similar to the last question. Find the area of the hexagon. Well, we know that if I draw that radius, because it's a hexagon, there's 6 of those triangles that you could draw in there. So 360 divided by 6 would make that angle right there 60 degrees. But I'm only concerned in half of it. So this angle right here is 30 degrees, making this angle 60 degrees. So right now what I have is a 30, 60, 90 right triangle. I know the side across from 60 is 12, so the side across from the 30-degree angle would be in. So right now I've got 60, or not 60, but 12 is equal to my in radical 3 side. So divide both sides by radical 3, and I get n to be 12 divided by radical 3. I'll rationalize that. I get 12 radical 3 over 3, and that reduces to 4 radical 3. So that is n. So this side right here, I know you can't see. Let's see if I can highlight it. That side right there of that triangle is 4 radical 3. Okay, so 4 radical 3. The hypotenuse, or sorry, yeah, the hypotenuse of that right triangle, or the radius of the triangle would be, or sorry, the radius of the hexagon would be double that, so 8 radical 3. You don't necessarily need that radius. I don't think any of the questions need that. Um, yeah, I guess eventually they do. So we do eventually need that, and I'll show you that when we get to question 13. So right now, finding the area of the hexagon. We know that this distance here is 4 radical 3. So the side length of the hexagon would be 8 radical 3. We double it, okay? And the reason I want to know that side length is because eventually I need to know what the perimeter of the hexagon is. The perimeter of the hexagon, if each side is 8 radical 3, the perimeter is going to be 6 of those, so it becomes 48 radical 3, okay? So that's the perimeter. Your apothem, that was provided for you. It's 12. So now area of the hexagon is 1/2 the apothem times perimeter. So a half of 12 times 48 radical 3. Okay. When you multiply all that out, you should get 288 radical 3. And that's option A. Okay. Now, I'll do this in blue. Part for question number 13 says, what is the area of the circumscribed circle? Well, the circumscribed circle is going to have a radius right there, which is the same as the radius for the hexagon. So when I find the area of the circumscribed circle, number 13, area of a circle is pi r squared. Well, I know what pi is, and now I know my radius is 8 radical 3, and I'm going to square that. So when I square 8, I get 64. When I square the radical 3, I get 3. I've got my pi here. 64 times 3 is 192. So this is going to give me 192 pi. So the area of the circle is 192 pi. Okay. Get rid of this. Get rid of this. Answer question number 13, or sorry, 14. So let's find the area of the shaded region. Okay. Well, if I think about this, let's go ahead. I'm going to go ahead and color in the rest of these. To find that all those shaded regions, the red and the black together, I would take area of the circle minus the hexagon. So the area of the circle, which was 192 pi, minus the hexagon, which was 288 radical 3. That would be all of these red shaded regions. Okay, but this question says we don't want all six of those shaded regions. We only want three of them. So then I need to take this amount and divide it by 2. Okay, so when I take 192 pi minus 288 radical 3 and divide that by 2, I end up with 96 pi. I'm going to write this 96 pi minus 144 radical 3. Okay, um, which now as a decimal, let's go ahead and get our calculator out because our answers are in decimals here. 96 pi minus 144 radical 3. So decimal is 52.17. So option C is your answer there. Okay. Going on to the next question. Says, what is the altitude of the parallelogram? Okay, now that because you've got a 45-degree angle here, it's going to be pretty useful to use that 45-degree angle. There we go. If this is your n radical 2 side, then this side over here is 3 divided by radical 2. I'll rationalize it. It gives me 3 radical 2 over 2. So that's my height. And that's that distance right there. Okay? So looking at these, option B. Find the area of the parallelogram. Area is base times height. So the base is 12. The height, we just said, was 3 radical 2 over 2. That 2 and that 12 will cancel and give me a 6 outside. So 6 times 3 is 18. 18 times radical 2 is 18 radical 2. Number 17, we've got, what is the total length of the bottom base? Well, I need to, in order to do this, I need to figure out what that is there. So I start up here and I look at this 4. And I know this is a trapezoid, so if that's a right angle, right angle, right angle, right angle. So this distance here is 4, making that distance there 4. Now this is a 30, 60, 90 triangle over here, so if the side across from 30 is 4, that's 8, and this is going to be 4 radical 3. So my height of my trapezoid, or my altitude of my trapezoid is 4 radical 3, making this side over here 4 radical 3. Okay. Now I get over here, and now that segment right there is part of a 45, 45, 90. It's across from the 45-degree angle, so this here is also 4 radical 3. So now I want to ask, what's the total distance of the bottom base? Well, it's 4 radical 3 plus this initial 8 that I had down there. So 4 radical 3 plus 8, option B. What is the height of the figure? We've already done that. We found it going through, and we needed that to find this 4 radical 3, or it was an intermediate value that we found as we were coming up with this here. It's 4 radical 3, option B. Find the area of the figure. Well, area is going to be 1/2 the height times the sum of your two bases. So 1/2 the height is 4 radical 3. The sum of the bases is 4 plus 8, which is 12, plus your 4 radical 3. Okay. I want to distribute that 1/2 there to that 4 radical 3, so it becomes 2 radical 3. And I've got 12 plus 4 radical 3. Now I can multiply 2 radical 3 times 12, I get 24 radical 3. And when I take 2 times 4, I get 8. And then 3 times 3, or radical 3 times radical 3 is 3. So we get 24 radical 3 plus 24, which is C. Working down the bottom, they ask me what is the height of the figure. So again, I'm looking for the altitude in this one. I notice right away that this is a 40-degree angle, so I cannot use special right triangles. I've got to use sine, cosine, and tangent. If they want to find the height, call that h. I got this angle here. That's opposite. That's the hypotenuse. So I'm going to say sine of 40 degrees is equal to opposite over hypotenuse. So 10 sine of 40 is equal to h. Okay, and when I type that into my calculator, should give me h to be approximately 6.43, which is option C. Now it asks, what's the sum of the bases? Well, to find the sum of the bases, what you need to do is construct that altitude there. And if that's 10 and that's 10, you know this is an isosceles triangle, or it's not isosceles, trapezoid, not triangle. So that distance there is 6. What we need to do is be able to find that and that. Okay? Well, again, I know that that's 10, and I know that this is now the adjacent side to 40. So I use the cosine of 40 is equal to adjacent over hypotenuse. So I'll go 10 cosine of 40 is equal to A. And typing that in my calculator, I get A to be about 7.66. Okay? Well, if this triangle here is the same as that triangle there, then both A, or this value here of A, that distance is 7.66, and this distance here is also 7.66. So now the sum all the way across the bottom, 7.66 plus 6 plus another 7.66. When I total all that up, I get 27.32. Okay. Now it asks for the area of the figure. Well, area 1/2 height times the sum of your bases. So we got 1/2 of the height, which was 6.43, times the sum of your bases. Well, we know that one base, I'm sorry, I messed that up. I messed question 20 up. Let's go back to 20 real quick. 7.6 plus 6 plus 7.66 is 21.32. We then need to add this top 6 to get to 27.32 is the sum of the bases, not just the bottom base. Okay, so that total of both bases is 27.32. Okay, so that value is going to be B1 plus B2 down in question number 22. And when you multiply all that out, you get 87.83, which is option C. 23, which of the following is the correct generic equation plan in order to, hold on a second, let me get rid of this stuff. What is the generic plan to get the shaded region? That's going to be the area of the sector minus the area of the triangle, which is option B. Okay, so B is your answer there. Okay, now 24 actually wants you to go through the work and actually do that. So we know that this is 60 degrees. Okay, we know that the diameter of this figure is 12. So if the diameter is 12, then this is 6, and this is 6. We can use some math here, knowing that that's an isosceles triangle, and it's a 60-degree angle here at the vertex. So this is also a congruent, so that's an equilateral triangle. So that's 6 as well. Now, if I wanted to find the area of the triangle, I'm going to have to draw that segment so it's perpendicular to the base, cutting the base in half, so that's 3. And now it's going to cut this angle up here, make that a 30-degree angle, make that a 60-degree angle. So if that's 30 degrees right here, then the side opposite it is n, and then the side opposite 60 would be n radical 3. So the height of your triangle is 3 radical 3. So if I'm trying to find the area of the triangle, it's 1/2 base times height, which is 1/2 your base of the entire triangle, okay, is 6. The height of that triangle is 3 radical 3. So now that's going to give me 9 radical 3 when I multiply it all out. So that's the triangle. The area of the sector is equal to x over 360 pi r squared. Well, x is this arc out here, which is the same as the central angle of 60 degrees. So we got 60 over 360 times pi. R squared is 36. So I multiply all these things together, I get 1/6 times 36 is 6 times pi. 6 pi. So now I go back to 23, and it was the area of a sector minus the area of the triangle. So 6 pi minus 9 radical 3. 25 says the rhombus has a 60-degree angle and sides of 8. What are the lengths of both diagonals? A lot of people ask, does it matter which angle is 60 degrees? No, it does not matter, but I'm going to let that one be 60 because it looks acute and this one looks obtuse. If that was 60, this has got to be 120 from what we know about consecutive angles in a rhombus or consecutive angles in a parallelogram. When I draw the diagonals, it's going to break those angles of 120 and 60. It's going to cut them in half. Okay, so this is going to be 60, and now that's going to be 30. All right, so you have side lengths of 8, and that means that's 8, side length of the rhombus. 30, 69 triangle, that's your 2n. So n is going to be, n is going to be 4. And then this side across from 60 is going to be 4 radical 3. Now it wants to know what the length of the diagonals of the rhombus are. So it wants that segment right there. Well, if half of it's 4, the other one's got to be 8. And then the other diagonal all the way across, if half of it's 4 radical 3, the entire thing has to be 8 radical 3. So that is option C. Find the area of the rhombus. Well, that's not too bad now that we know what the two diagonals are. Area of the rhombus is 1/2 d1 d2. So we got 1/2 of 8 times 8 radical 3. 8 times 8 is 64. Half of that is 32. So 32 radical 3. Find the area of the irregular shape. Well, it's not too difficult here. Draw that segment. The bottom then here, this rectangle is going to be 32. Okay, so instantly gets rid of option A. You know that is 8 because it's a rectangle. I'm going to draw that segment down to get a right angle. When I do that, it's an isosceles triangle up top, so it's going to cut that 8 into half, so that's 4. I'm going to find my height. Okay, you're going to have to use the Pythagorean theorem. Okay, well, I know 4 and 5 group up with 3 to satisfy the Pythagorean theorem. Okay, they're a Pythagorean triple. So my height of this thing is 3. So now finding the area of the triangle, area is 1/2 height times base, or base times height. So you get 1/2. Your base of this triangle, we're trying to find this entire triangle. Okay, so that triangle's base is the 8. And the height of that triangle, that distance there that we just found, was 3. Okay, so this triangle up on top is going to have an area of half of 24, which is 12. So now 12 plus 32 is 44. An equilateral triangle has a perimeter 18. Leave your answer find its area, leave your answer in simplest radical form. So area of 18, or sorry, not area, but a perimeter of 18 is equilateral. So each side is 6. Each angle is 60 degrees. Let's write those two in, because what I need to do to find the area of the triangle, which is 1/2 base times height, I need the height. I need the altitude, right angles. So I just need to draw that down so I get a right angle. It's going to break this up to a 3. Okay, and this is your 2n. This would be 30, so 3 is going to be your n. So this height here is going to be 3 radical 3. So area then is 1/2 the base, which was 6, and the height, which is 3 radical 3. 18 times 1/2 is 9, so I get 9 radical 3, which is option B. Okay. If you look back to previous questions in this test, you would have found that exact same triangle as part of number 24. Number 29 says a circle has an area of 412 square feet. Find the diameter of the circle. Well, we know that area is equal to pi r squared for a circle. So I'm going to take 412, which I know is the area of this particular circle, equal to pi r squared. I'll divide both sides by pi, so I get 412 over pi is equal to r squared. So now I'll take square root of both sides. and that will leave me with r equal to the square root of 412 divided by pi. Okay, so typing that into my calculator, square root of 412 divided by pi, pi, hit enter, 11.45. Now that's r, that's my radius. They want the diameter, so I need to double it. And my answer is 22.9, so D. Question 30, pretty similar process, but now you're working with a different formula because you're working with a rhombus. It says rhombus QRST has an area of 137.9 square meters, RT is 12.2 meters, and find QS. If you were to draw a picture, you're going to find out that that's one of your diameters. This is your other diameter. So we know area of a rhombus is 1/2 D1 D2. So area, 137.9, is equal to 1/2 D1 times D2. Well, D1 I know is 12.2, so I'm going to erase that and write D1 as 12.2, and now D2. Okay, well, that's going to give me 137.9 is equal to 6.1 times D2. Divide both sides by 6.1, so you get 137.9 divided by 6.1 is equal to D2, and that turns out to be about 22.6. So option C. 31, find the area of an isosceles trapezoid that has a perimeter of 52. The measure of one base is 10 yards greater than the base. The other base, the measure of each leg is 3 yards less than twice the length of the shorter base. So you got an isosceles trapezoid. So we're going to draw a picture. The best thing to do is draw a picture, organize your information. Pictures don't have to be great, mine aren't. It says the measure of one base is 10 yards greater than the other base. So this is the bigger base. So that's the one it's talking about. It's 10 yards bigger than the smaller base. Well, I don't know what the smaller base is, so I'll let it be x, making this one 10 plus x. Okay? The measure of each leg is 3 yards less than twice the length of the shorter base. Well, twice the length of the shorter base would be 2x. 3 yards less than that would be minus 3. Okay? Now, we need to know what x is. And they give us a method of doing this by telling us the perimeter. They tell you that the perimeter is 52. So if I add all these x's up and the other values there and set them equal to 52, I should be able to find x. So you got 2x, there's 4, there's 5, there's 6 x's. There's a -3, a -3, and a +10, so that's going to work out to be plus 4, should equal 52. Okay, that's perimeter in terms of x is equal to the numerical value of the perimeter. Solving this for you get 6x is equal to 48, so x then is equal to 8. Okay, now it asks you to find the area of the isosceles trapezoid. Okay, the area of the isosceles trapezoid is equal to 1/2 the height times the sum of the bases. Okay, well, right now you know that this distance here, its x, is 8. This one's 18. 2 times 8 is 16, minus 3 is 13. That's 13. In order to fulfill my formula here, I need to know the height of this thing, so I'm going to draw that in. Okay, I'll draw this one in as well because it's isosceles, so that's going to help me determine that this here is 10, or sorry, 8. Okay, because the top is 8. Making this segment here 5 and that one 5. Okay, if the whole thing across the bottom is going to add up to 18, 5 plus 8 plus 5 gives me 18. So now this is 13, this is 5. Pythagorean theorem is going to tell you that that height has to be 12. So the height of my trapezoid is 12. So I'll go 1/2 of 12 times the sum of my bases. The sum of my bases is going to be 26. 18 plus 8 is 26. Half of 26 is 13. 12 times 13 is 156. So option C. 32 says find the numerical height of a parallelogram whose base is x plus 15, whose height is x. Okay, so the base is x plus 15. the height is x. We know the total area should equal 1,000. Okay, so the area of a parallelogram is base times height. Well, we've got 1,000 should equal the base of x plus 15 times the height of x. Well, that's 1,000 is equal to x squared plus 15x. Subtract 1,000 from both sides. X squared plus 15x minus 1,000 is equal to 0. Now you're going to factor this, and the two numbers that multiply together give you negative 1,000 and add up to give you positive 15, or negative 25 and positive 40. So now that will give me x to be positive 25 and x to be negative 40. I'm talking about a distance here for x, so it can't be negative. X has to be 25. So my only option would be A. 33, find the area of the shaded region. Okay, well, the area of the entire, if I want to find the area of the entire rectangle, it's going to be 10 times 5 radical 2. And when I multiply those together, I get 50 radical 2. So the entire region is 50 radical 2. But I need to remove from that entire region these triangles. Well, these triangles, the height, or sorry, the hypotenuse is 5 radical 2. And we know, because that's a right angle down here, that that's a 45-degree angle. That's a 45-degree angle. So this distance here is 5. That distance there is 5. So the area of that triangle is 1/2 base times height. Base is 5, height is 5. So you get 25 halves. Okay? For that triangle right there, its area is 25 halves. But I've got two of them. So let's take that 25 halves, multiply it by 2, and that total red shaded area would be 25. So to find the black shaded area, it'd be the area of the entire rectangle minus those two triangles, which would be 50 radical 2 minus 25. 34, a little bit of thought behind this one. We did several questions like this in class. A bicycle tire has a radius of 33 centimeters. So you got a tire here. That's 33 centimeters. Okay, it says if a rider can pedal fast enough to make the tires rotate 3 times every 2 seconds, how far would the rider travel in 7 seconds? What I'm going to try to do, I think the easiest thing for us would be able to determine the answer to this is to first find out how far he travels in 1 second. Okay, so we talked about traveling distance around a circle being circumference. Okay, so when a car is moving, however many times the wheels rotate, or a bike, how many times the wheels rotate there, you are covering a distance, and that distance is how many times the circumference of your tire gets repeated over and over again. Okay, so find the circumference of this thing, of this tire. It's 2 pi r. So 2 times pi times 33, so you get 66 pi is the circumference of your tire. Okay, now if I can rotate this thing 3 times every 2 seconds, okay, so in 2 seconds I would rotate 3 times. So I'm going to multiply this by 3, and that's going to give me 198 pi. Okay, and then that's centimeters. Okay, so right now I know that every 2 seconds I'm going to travel 198 pi centimeters. Okay, or I'm sorry, every 2 seconds, that's how far I'm going to travel. I'm going to rotate 3 times. Okay, so 198 in 2 seconds, 198 pi. Okay, well, if I just want to find out how far I go in 1 second, okay, doesn't this get divided by 2? Okay, the amount of time gets cut in half. Okay, so if I divide that by 2, I get 99 pi. Okay, so I travel 99 pi centimeters in 1 second. The question is, how far do you travel in 7 seconds? Well, now if I know I'd go this far in 1 second, let's take 99 pi, multiply it by 7, and that's going to end up giving me 693 pi. Okay. Now, the questions we did in class were a lot simpler than this, I think, in terms of this part. When I tell you every 2 seconds and how far would you go in 7 seconds. This would be easier if that number there was even, if that was an 8 or a 10 or something like that. Um, but this, I think, would be the quickest, most efficient, probably easiest way to do it. Break it down, see how far you go in a second, and then multiply that 1 second by however many seconds the duration of the bike ride is going to take. Okay. If you have any questions about this test, any particular question that you need to come see me about, you still don't understand, don't hesitate to come see me. Um, Make sure you do that though before you take the retake.